fellow mathematician. Welcome to Calculus 2, which is mostly done in second year, depending on the university where you are learning, or in first year, second semester. We are looking at integration by partial fraction, and today we are considering the integration of repeated linear fraction. And we have this example here for the purpose of illustrating. We are given this example here, which we are going to consider. You have x, integral of x divided by bracket x minus 1, bracket x minus 2, bracket squared. So what we do, we split this denominator this way. We are going to have a integral of a divided by x minus 1, then dx plus integral of b divided by x minus 2 dx integral of c bracket x minus 2 squared. So the first step which we are going to do here, it is to get the value of a, b, and c, which are a constant. So we are going to have x divided by x minus 1 into bracket x minus 2 you square. This is equal to a over x minus 1 plus b divided by x minus 2, then plus c divided by x minus 2 we square. So what we are going to do, we are going to multiply both sides with this denominator on the right hand side and on the left hand side. So we shall multiply with this denominator on the right hand side and on the left hand side. So when we multiply on the left hand side with this denominator, we are going to be left with x, which is equal to x minus 2 squared a. We are multiplying both sides with x minus 1 bracket x minus 2 squared. So when we multiply with this here, x minus 1 will cancel, plus b into bracket x minus 2 into bracket x minus 1. So one of these ones will cancel when we multiply. Then plus c into bracket x minus 1. Yeah, we are going to be left with x minus 1 when we multiply there. So the objective is to obtain a, b, and c. We can start by setting. We can set the value of x to be equal to 2. So you can see here, when we set the value of x to be equal to 2, a will reduce to 0, and also b will reduce to 0, and we will be left with c. So we set that. So where you have x, you put 2. So 2 is equal to 2 is equal to 2 minus 2. You square here a, you want, plus b into bracket 2 minus 2 into bracket 2 minus 1 here, plus c into bracket 2 minus 1. Clearly you can see here you have 0 squared, which will reduce to 0. This here you have 0 times b, which will reduce to 0, plus 2 minus 1 is 1. So you have c 2, meaning that our c is equal to 2. Our c is equal to 2. Next thing, we set x to be equal to 1. When we set x to be equal to 1, we are saying that both b and c will reduce to 0, because here you have, so let us substitute. So you have 1, substituting here, 1 is equal to 1 minus 2 you square you have a plus b into bracket 1 minus 2 multiplying by 1 minus 1 plus c into bracket 1 minus 1, which is equal to, here you have negative 1 squared a plus b 0. This is 1 minus 1 is 0, so you get 0 plus c into bracket 0. You can see clearly 1 is equal to a. So our value of a is equal to, our a is equal to 1. Next, we want now to get b. So to get b, we can set value of b. We can set x is equal to 0. So set x is equal to 0. When we set x is equal to 0, we are going to substitute here. So we are going to have 0 is equal to bracket 0 minus 2 squared a plus b into bracket b into bracket, we are substituting here, x is 0, 0 minus 2 into bracket 0 minus 1 plus c into bracket 0 minus 1. So which is equal to, here you have negative 2 squared will give you 4a plus negative 2 times negative 1 will give you 2, so plus 2b. Here you are going to have minus c. Then we substitute, we have 0, which is equal to 4a. The value of a is 1 plus 2b. The value of c is 2 minus 2. So clearly here you can see 4 times 1 is 4 minus 2 plus 2b. This is equal to 0. So 4 minus 2 is 2 plus 2b, which is equal to 0. Negative 2 is equal to 2b. Taking negative 2 the other side, meaning that our b is equal to negative 1 at x is equal to 0. So now, once you have obtained our constant, we are going to come and substitute them here. We shall substitute them there. Now, we have obtained our a is 1 and our c is 2 and our b is negative 1. So we are going to plug them here. So where you have a, you write 1. Where you have b, negative 1. And where you have c, you write 2 as shown here. So the integral or the antiderivative of 1 over x minus 1 will give you a natural logarithm modulus of x minus 1 minus, there is a negative here, natural logarithm of modulus of x minus 2 plus, now this part here, we can integral of 2 dx over x minus 2 squared. Here we are going to let u to be equal to x minus x minus 2. Then du dx will give you 1 when you differentiate, which implies that our du is equal to dx. So here we shall have 2 integral. 2 can come out. Instead of dx, we have found our dx is du. We write du divided by u squared divided by u squared. So this can be written as u power negative 2 integral, there is 2 there outside, du, which is equal to, you want 1 here, and you divide by the result. So we will have 2 u power negative 1 divided by negative 1, which is the same as 2 over negative 1 u. When you take u down, it will give you negative 1 u. So when we come here now, we can substitute with our u. Our u is x minus 2, x minus 2. So we come here and write our result. So the result here will be, remember there is a negative here, we will have negative 2 into bracket x minus 2, which we can write our result as we can combine these two, natural logarithm of x minus 1 divided by x minus 2 modulus minus 2 divided by x minus 2. So here, integral of x minus 1, x minus that is this. This part here, we have done it here by letting. We have let our u to be x minus 2, du dx to be this, du is equal to dx. Then we are substituted here where you have x minus 2, we have written as u squared, and we have taken this up to be negative. So integrating this, we have found it is 2 over negative u. So here, plus some constant, plus some constant c. Remember there is a constant here in the final answer, plus some constant.